Thank you, thank you. So my name is Buck. As he mentioned, I am from Microsoft. I will disappoint all of you. I have no PowerPoint slides. I know that's a bummer, but I don't have any PowerPoint slides. We're going to do everything in notebooks today, and you're going to be able to get these notebooks and bring them down. You don't even have to install anything on your laptop. We're going to be running from a notebook server, or if you do have Jupyter installed locally, or if you want to use, I think Collaboratory is the one that Google has, you're welcome to pull these down and use them. You're free to use them. You're free to redistribute them. You're free to reteach this course if you want. Fine. In fact, that's fine. We're going to be covering off on a few Microsoft technologies, but no salesy stuff at all. This is independent of that. This process can be used with anything. So I wanted to give us a vote, though, because this is a 90-minute session and it's 11:15. That means I don't let you go to lunch until 1, and I'm afraid some of you look very hungry, and I'm a big guy, so I'm afraid I would look a little tempting up here. So let's take a vote. We have 2 ways we can do this. This is a half-day course that I normally teach that I'd condense down to 90 minutes, giving you very little time for the labs. What we can do is instead of giving you even that amount of time for the labs, I can go through everything. You can still do the labs if you want. You'll have them for later. All the instructions are here. But we can use that time to interact better on the material itself, because we're not focusing on the data science-y part, even though that's there. We can do that, and I can probably land us in about 65 minutes. What do you think? People who would like to land and get out of here for lunch earlier than 1. Okay, most people. I'm not going to vote for the rest of you. You just got to be fair, you will have all the materials. And you can do these labs as many times you want. It's very simplistic. And in fact, once we go through this, you can replace the lab portions with your production code. That could be R or SQL or Python as it is here. And you'd be able to make this into a production environment rather than a teaching environment. Make sense? Sounds okay? Let's get a quick poll of the audience. People who identify themselves as data scientists, meaning you care and feed models and experiments mostly throughout your day. Good stuff. Those of you who would classify yourselves as data engineers, which is everything else except building models all the time. Raise your hands. Those of you who are data professionals, you deal with everything from OLTP type data and maybe some sort of SQL environment all the way through reporting like in Tableau or Power BI. Raise your hands. Okay. And then there's a mix of us that do a lot of those things. How many of you do everything and whatever you're told all the time? Okay, I've been married for 33 years. I take instructions very well. Actually, my wife and I were both in the military. So she's very well trained as a marksman, so we have very civil arguments in my house. All right, let's get you started. We are going to be using notebooks. How many of you would like a quick 2-minute notebook overview? Okay, notebook is a web page with an engine. And in that engine, there are things called cells, and the cells can be one of 2 things. They can have text in them and pictures, or they can have code. If it has code, you can run the cell. You can run the cell anyway. When you run the cell, it will run the code using whatever kernel it's called on the server. So there are lots of these around. You can install it. It's from a place called Jupyter, Jupyter, Jupyter Notebooks they're called. And these are written for Python primarily, but they run R and other things. You can also find them hosted. We have one. It's free. You will need to log in, but you're not going to be charged anything or anything like that. This is just so you have an environment. So that's what a notebook is. It's a web server that can run code. People who know what notebooks are will say, no, that's not what it is. It kind of is. I'm too old to argue. All right, so what we're going to do is I'm going to take you there. You're going to do one of 2 things. I'm going to show you both, okay? And we're going to do this part I do want you to do. And then the rest of the workshop part, I'll go through the code if you wish, but we won't drill in on the code as much as we would in like a 2-day. So I've got my screen kind of really big here. So this is where you go. aka.ms TDSP Notebook. aka.ms TDSP Notebook, aka.ms/TDSP, that's Team Data Science Process. If you go to that notebook, you'll get a view similar to this one, I hope. And you'll get a place up there in the right where it says Buckwoody Notebooks for you to log in. And when you log in, you just need some sort of live account. You can get it from hotmail.com or live, or you can use your Google address, whatever you happen to have. If you don't have a live account right now, don't worry about it. Do all this later. Or do it now, and we'll talk it through, okay? Has everybody at least gotten that URL down? Everybody got that down? Good stuff. Go like this. I teach college. I have to tell my students, go like this so I can know that they're listening. All right. I'm going to go over this, and then I'm going to show you how we'll open the notebooks and so on. The team data science process is something that we've been asked to create. And the reason why is all of you know how to do the algorithms and the math and the models and all those kinds of things. We know our data science well, and we know other parts of this. But what people keep asking us, both the business and the data scientists, show us how to do this, like for real. Like in real production environments. Or the data scientist is sitting off in her office, she's got a computer and she's got R on it, and she goes and gets data. Nobody knows she has the data, so it's super insecure, but don't get me started. She's got the data, she's working with it, they tell her, we need this thing, and she goes, okay, and she sits in the dark for several weeks, and then she comes back with tablets from the mountain. Yea, the data doth verily say. And they're like, there's like an iPad tablet, and there's like a Kindle tablet, and the tablets say this, and they go, oh, wow, and that's what's been happening. But now the IT department says, where did she get that data, and did you know we have BI, and we could have done that by just doing a historical query, and do you know about SQL, and so on. And so they're being asked to integrate into the business. That's what's been happening. And also the business turns around and say, we're paying her a lot of money, and we don't know what she does, and we'd like her to be part of everything else. And so we're getting this push to be part of a team now. And do you really want your data scientist, who makes a lot of money, to be turning little A's into big A's, doing data engineering most of her day? Do you really want that? Or do you have folks that can handle that for her? Yes, you want her focusing on the things she's working on. Does that make sense? Everybody tracking? Okay, good. So what we have is this thing called the CRISP-DM, C-R-I-S-P-D-M. You ever heard of this? Anybody ever heard of this? This is the cross-industry standard process for data mining. Data mining is sort of the precursor to ML. In fact, if AI from the 70s and data mining got together and had a baby, that would be the new machine learning. That's literally where those things came from. Same disciplines, no difference. And so this CRISP-DM was great, but it was really just three big pieces. Data comes in, you do something to it, and then data goes out, which is kind of broad. And it's also just aimed at one person. So what we did is we backed up and took a look at frameworks like Agile, DevOps, lean technologies, extreme programming, all these other kinds of things. And we wanted to make sure we could fold data science into that, because it doesn't always fold well. One part of Agile involves something called continuous integration and continuous testing. And continuous testing is very difficult to do. What you do is you have a program and you say, when Buck puts in his name, you make sure that it's only letters, it's not numbers, and so on. And then on the other end comes an automated test that says 0 or 1. Yes, it did. No, it didn't. You really can't do that with a machine learning algorithm. You can't say, will this give a good prediction or not? It's always going to give you a prediction. So it's hard to do the continuous integration. So we've done the work around making a team process for this. It's highly documented. You'll find everything here. Now let's go back to our notebooks. If in fact you have signed in, even if you haven't, you have two choices. One is to use the word clone. So if you signed in to my notebook, then you want to click the button right there that says the word clone. What this will do is make an Azure notebook environment for you, and now you have a copy of my notebook, and you can change it to your heart's content. You can always come back here and re-clone it if you wish. Now you say, well, I don't have an Azure notebook and I don't want one. I want to do this locally. Here's what you would do. Click on the word libraries at the top, libraries. When you click on my libraries, you'll see the team data science process with Python. Just to the right of the link, click it so that the line is highlighted. Click it so that the line is highlighted, just like this. And then you'll see a button there called download. And you can also do this even if you clone it. That will give you a zip file of my entire environment, and you can have it, and you can put your name on it, and you can tell people you invented it. But you'll be lying, and you'll know that when you go to bed at night. You won't be able to sleep with yourself. All right. So let's go back into the team data science with Python. You're in this page, and let me walk through this first part. This first part's in something called a Markdown file. Markdown is a lobotomized form of HTML for people who can't write HTML. What you do is you put certain markers in it, and it marks up the language to have things like headers and italics and bolds and so on. Very simple to work with. So I tell you what the team data science process is here, but the important part is this. I'm not going to zoom in on this right now. I'll just read it to you. It's a data science lifecycle definition. Data science lifecycle definition, and it's a standardized project structure and tool set you can use to do data science. That's what it's for. It's going to help you get through everything. The interesting thing is that if you start with the process, this will often drive the technologies that you need to worry about or the things you need to learn. So sometimes it's best not to start with the tech, but to actually start with the process to solve a problem. Does that make sense? Okay, good. If anybody has any dissenting opinions or you have comments or whatever, feel free to raise your hand and keep it to yourself. No, I'm kidding. I'd love to hear back. You can ask questions anytime. I may or may not answer it. I may tell you I'll answer it later, or we may stay on track. Is that all right? Like this? Everybody like this? Okay, good. Is it cool enough in here for you? I am freezing. I'm from Florida, so anything less than 90 is like... All right. I have if you want a really complicated machine learning-y, all kinds of stuff from Microsoft kind of example, there's a link here called Biomedical Entity Recognition using the Team Data Science Process template. That's highly documented. There's a link there. Do that. Every link I show you, I want you to right-click and open in a new tab. I don't want you to lose where you are. We good on that? Okay, we're moving quick. If we move too fast, ask your neighbor what I just said. All right. So we've got this cloned idea. That's here. That's the link. And then if you're brand new to Azure Notebooks, I've got a link there. And then that last link is what I wanted to point out. Microsoft actually has a landscape of things you can use for artificial intelligence. Everything. Did you know there's AI built into Excel? Ever heard of flash fill? Write down in your notes, look up flash fill. I'm not going to cover it now. PowerPoint now, when you drop a picture in PowerPoint, if you paste a picture, it will automatically caption it for you in case somebody can't see the picture. That's all being done with image recognition and other things. So definitely check out some of the things. This article covers all that. We have a series of cognitive services that are just APIs that you can call. So you don't have to write machine learning. You can write Python or R or C# or even curl and just make an API call. But then we have a full suite of AI tools to write data science-y things, okay? I'm not going to bore you with that here. This is not a sales pitch. That isn't either. That's an audit of what we have. So definitely check that out, but do it later. Everybody scroll up and click the button called, or the link called 0-tdspworkshop.ipynb. That stands for IPython Notebook. Let me show you that again. Right here at the top, TDSP Workshop, IPyNB. You'll notice there's another notebook, and it's called Presentation. And it's exactly the same thing, because as I go through this, I'm going to be changing things, which automatically saves. So I've got a copy of it without things saved, so I can copy it back over for the next class. Right? Okay, has everybody done that wants to do that? Everybody else is just listening? Now what we're going to do is I'm going to walk this in the next little bit here. One of the things you can do, let me zoom in for us so we can see this well. Let's go to 150 there. But one of the things you can do that's kind of interesting inside a notebook is that there is a slideshow feature. Most people that are using PowerPoint are using it incorrectly. If you have so many fonts on your slide that it looks like a ransom note, or if the only colors you are using are black and white, you are doing it wrong. But I digress. By the way, I'm speaking to every college professor you've ever met, ever. As long as you make the fonts about 4 points, then that's a college professor. All right, I'm sorry, was that out loud? Here we go. So what I'm going to do is I'm going to actually kick over to the slide view of the notebook. So this is just walking the notebook. So now I can show you in a large font what's happening. In a workshop, I normally don't go to the slide view because I'm telling you something and then you're doing some work. But since we're going to go a little quicker today, I may bounce back and forth. Is that okay? Yeah? Okay, good. Haven't lost anybody yet? All right, good. So we've already talked about what the team data science process is. I'm assuming you're interested in that because you're here. I hit the space bar here, and here's what we get. The TDSP comprises the following key components: a data science lifecycle definition and a project structure. Note, you can follow a full example using here. We talked about that just a moment ago. Space bar. All right, this workshop will guide you through a series of exercises. Now, what I've done is two things. There's a section of code where you're supposed to type. You'll see the words to do. You can hit Control F and find all the to-dos and do the work. If you were to do these, this is about a half-day workshop. If you were to do it, it's about 4 or 5 hours. If you were to do the actual work itself, and this involves things like some data engineering and other model selection and so on. I'll leave that to you to do later. We're going to jump to the answer. The interesting thing is I say in here, you're supposed to do the work, but you know, if you get stuck, you can ask a neighbor, you can ask the internet, it knows everything, and then you can also, there's a cheat sheet. I have the answer sheet. So we're going to do that. So I'm going to go ahead and leave slide view. I just do that by clicking the big X there. And there's nothing magic about the fact that I was in slide view. Let me make this a little bigger because that's a small screen and we got folks in the back. You guys see that okay? You don't have to read every line. I'm just going to kind of, is that all right? All right, good. All right. Sorry about that. All right, so it looks kind of like this. And again, to run a cell, if I were to double click this cell, by the way, that's Markdown. Much easier than HTML, right? Okay. The interesting thing to me is HTML actually comes from something called SGML, which was invented a long time ago, and HTML was the Markdown of SGML. And now we've got a Markdown, which is the Markdown of HTML. Next, I think they'll just be plain text, and we'll go back to INI files. What you do when you want something, if you want to set a cell as Markdown, you do that. If you want it to be code, you do code, and so on. And then you simply run it. And again, you can see here, at least in the Azure notebooks, whatever kernel you install, that's the code that can run. So I've got R, F#, Python, Python 2, 3, 3.6, and then R. We'll be adding more kernels as time goes on. Okay, that's an aside. You don't really care. All right, guide you through a series of things, and then it says, try to figure out the labs by yourself. Then search the web, then ask your neighbor. And if you're really stuck, check out the answer sheet. Right-click, open in new tab. When you right-click and open that notebook or that particular file in the tab, I do all, this is the teacher's answer sheet. So there you go. There's all the answers for all the labs. So we'll be bopping back and forth for that. And again, you can do this later, okay? It's completely okay. All right, so the first thing we do is when we're getting ready to do a data science project, the very first thing we do, we need an environment to work in, we need our computer set up, we need to find out our team members and so on. So we're going to assume we've done all those things. So all I'm going to do here is I'm going to bring in the Pickle library. Folks that are not familiar with Python, raise your hand loud and proud. Raise your hand loud and proud. Okay. Python uses libraries just like R or anything else, any other language would. This particular one will serialize what's in memory down to a file so that you could then read that and it acts like a million tiny fingers retyping everything that just happened. Conceptually, it's a lot like a transaction log in a database. Physically, it's nothing like that. It's just a memory dump. Everybody okay? All right. If you have questions, do your thing. Here we're going to bring in a bunch of libraries. I'm going to use 2 for the particular thing we're going to do today, and we'll talk about what we're going to do today. But I'm going to bring in a naive Bayes, and I'm going to bring in a decision tree. Those are the families I'm in. Guess what? The hardest part of data science is not the algorithms. Not even close. Then I'm also going to bring in pandas, which is awesome, to do some number things, and then NumPy as well to work with numbers. And then I'm going to write things in and out, so I'll need a comma-separated value file. And then here is the team data science process. Oh, this is so awesome. I'm going to go to this, and I'm going to enter our RISE show here. Come on. Come on. Work with me here. All right, here we go. Go back, go back. All right, let me get this to a size we can see. All right, I'm going to write this off for you. Number 1, The team data science process is 5 phases. 5 phases, here they are. Number 1, business understanding. Number 2, data acquisition and understanding. Modeling, deployment, and deployment is an overloaded term. We'll talk about that in a moment. And then customer acceptance. At the bottom is an AKA link. This is our link shortener, and you can find all the documentation, and there's a ton for TDSP at aka.ms/TDSP. Good? All right, what's in each phase? Well, in the first phase, in business understanding, the first thing we need to do is define our objectives. We're going to talk about that more in a moment. We then need to figure out where the data is. The order of this stuff sort of matters. We're going to talk about why in a moment. Then we'll bring in the data. We call that ingesting data. How many people know what ETL stands for? Somebody raise your hand. All right, you raised your hand. What does ETL stand for? Extract, transform, and load. What does that mean? Good. Yep. Okay, so he said that you bring the data in from some source or sources, and you transform it in some way, change it in some way to be homogeneous, to be palatable to the system that's going to consume it, and then you load it into some data store ready to be queried, correct? Does that sound right? You're not going to do that with this. We're going to do ELT. We're going to do extract and load and then transform at the very last possible minute. Why is that? Because R has 9 data types, give or take. SQL Server has 30. So you want to figure out what you're going to do, what technology you're going to use at that step, and transform it to be best used by that step. Everybody clear on that? We'll talk about that more in a moment. Next, we update the data. We explore the data, rather, and we update the data. The first thing we do, which is quite different than inside business intelligence, is we query the data to see lots of things. Its shape. We'll talk about that in just a moment. Next, we update that data because now we know what we're going to do. We've chosen a family of models. Models are not algorithms. Models are what algorithms make. And then once that's done, we'll know which features we need, and then we'll need to know if we need labels as well if we're doing a supervised training set. If you don't know what these things are, I'm going to help you out in just a minute. Next, we're going to operationalize, a term only a marketing person could appreciate. No, it actually has a meaning, and the reason why is deployment was used originally, but deploying a machine learning model is not the same as operationalizing it. Those are actually overloaded terms, so we call this phase operationalization. Finally, we have the customer acceptance. It's not done until the customer says it's done, and data science is interesting in that no model is perfect. So the model needs to be retrained all the time. And so there's a virtuous circle that goes around inside machine learning. We good? All right, let's jump into the phases then individually as we walk through. Yes, ma'am, hit me. So the crisp DM, the question was, how is that different from the crisp DM? So far, the first or the second box to the fourth box are exactly the same. The problem is there's not this idea of a team involved and a project, and when you do your business discovery, talking with DevOps people and business people that are outside the process and legal people and so on. So this is an enhancement of the crisp DM. Crisp DM is great, and it fits inside of here. So we didn't whole cloth rip it out. And this was an industry thing, by the way. We worked with other people doing that. Great question. Other questions on that? Yes, sir. It's always going back loops. The question was, it's not a progression that ends up somewhere. We actually loop, and you absolutely loop. Which makes data science very different. When I do a predictive model, I'm not done. The team's used to disbanding and going on to the next project. I'm like, no, where y'all going? We got stuff to do. Come here. And so it's a virtuous circle that you'll maintain. All right, lab 0, clone the TDSP structure. This has already been done for you. We have a GitHub with all of the documentation we're going to refer to today out on GitHub with all the directory layouts that you need. It is not specific to a technology. You don't use Microsoft stuff to do this. It's already in this notebook structure, so you don't need to do this right now. However, when you're starting your next new project at work, you can use this command right here, which is just the get clone command. For those of you familiar with get, if you're not familiar with get, install and get, and then just type that command, and you don't have to understand how get works. This will just copy everything from the web for you. Every lab will have a verification, and it says check that the file structure matches what you see in this reference. I'm going to right-click and open the directory. This directory is just the GitHub. Let me change the size here. Okay, and the directories look like this. There's code in here, there's docs in here, there's sample data in here, and there are some open source licenses things. This will tell you all about what that directory structure is supposed to look at. Let's drill in on at least one of them. Docs. You can see that we have data dictionaries, models, project documentation. We've got our charter, the exit report, everything else that we need to do. Also, you can diagram how you filmed your or set up your solution here. Okay, a little different again than the crisp DM. All right. Okay, back to the thing. So this lab is technically already done. So you would simply go back to the Python notebooks, and if you'll look, you don't have to do this, but if you'll look, there's directories in here, TDSP project template, and if you'll look, there's the directories, and so that was your validation for this lab. Nicely done. Nicely done, folks. All right. So now what we need to do is download our project planning documents, and it says the instructions are to open and review this reference. Download either the Microsoft project template or the Excel file, and then to verify, open the project template or the Microsoft Excel file. If you don't like Excel, there's a free viewer, and you can convert that to some other lesser product if you want. I'm going to right-click this guy and open that directory for you. And if you go in here, and once again, let me zoom out on this for you guys. Again, you can be doing this along with me. We're moving quickly. Is this okay? All right, everybody tracking? Nobody's lost yet, right? Okay, good. All right, so you can see here we have all the different phases already built for you in a project plan that you can download for free. Once you download that plan, if you double-click inside something, it tells you everything. What the task is, who would do it, and this will also help you define your team. The data scientist, the data engineer, the business representative, the DevOps person, and so on. Okay? And you're like, this looks a little heavy for a small project, and it is. But we don't do small projects. We work with really, really big companies, and they want this stuff done correctly. So this is not amateur hour. This is when you want to really lock things down. For those of you who are, anybody here affected by GDPR, you've got requirements to store all your project documentation in a location. We have that covered for you. I turned this into this comes from our field, by the way. When we send data scientists off, we have consultants for data scientists. They use this project template to do their engagements with customers. The military, the government, Costco, Starbucks, small places you may have heard of. And then once that's done, I went ahead and turned that into an Excel spreadsheet. So it's the same information in Excel. Are we good here? Okay, there's lots of stuff, and it tells you all the different things you need to do. Okay? So that's that phase. So we've now got our project. We've started our environment, and we've got a project. We know who our stakeholders are. We know who we're working with. We know who our team is. We have an idea of how long this will take. A general idea. By the way, this is a little trick. I used to work at NASA, and they would come and ask us project plans. When will you be done? Because it's government, right? And they'd say, when will you be done? We're going to space. It's not like you do that every day. Like, it's not the T, right? I mean, I'm like, I don't know. So what we found was you can tell anybody that you're 50% done, and they'll go away. And you could just be 50% done to the day you're not. And it works out. The day we started, we're like, well, we're about 50% done. A few technical things we're working. Oh, great. And the congressional committee would wander away and be like, okay, let's get started. And this is not being recorded, is it, son? I need this job. Okay. Let's get this a little bigger even still. All right. Now we are finally to phase 1, business understanding. If you will right-click on the documentation reference here and open that one. I'm having you open a lot of things in here. Everything is here. All the life cycles, what the goals are, how to do it, how to get your objectives, which group does it, how to do all these things, what are the artifacts you need to fill out, what is the next step, and so on. Everything's there for you. You don't have to follow it. but it's there as a guideline. Does that make sense? But let's drill in on this a little bit. Phase 1, business understanding. We were talking earlier about a grocery store I went to recently. And in the business understanding phase, the data scientist was talking to me and they said, I've been asked to work on this project and they said, you could help me. I said, okay, tell me what you're doing. And he was a recent grad, PhD, super bright person. And he had been told, we need for you to do a traffic analysis of the store. It turns out that in a grocery store, the edges of the store lose them money. Did you know that? I didn't know that. They don't make very much margin in groceries. So the bread, they throw out most of that. The fruit, they have to throw out most of that. The deli, they have to throw out most of that because it goes bad. And the pharmacy, if they have one, super expensive to keep the licenses. The meat counter, oh my gosh, so much money for the cleaning and sanitation for that. Loses some money. So how are they making money? They make money with the center of the store. The frozens. The frozens, they can make themselves. They last a long time and they can mark them up. So they want to get you to the middle of the store. And so I looked at the PhD and I said, interesting, are you sure you want a traffic analysis? Because it sounds like that's what you just told me. And he goes, well, yeah. I said, you want to get people to the middle of the store, right? Yes. That's a behavioral modification process. You actually want to drive people, so you want to discover features that would force someone to go to the middle of the store and buy the thing, right? Isn't that what you're really doing? So the number one problem inside data science, the hardest thing that you will do, the most difficult task to master, is not the math. It's defining the right question. Defining the right question. Anybody disagree with that? Any stats professors I can take on right now? Please come on. Every once in a while I get a bunch of them. Here's the problem. In stats, by the way, in C# or Java or SQL, if you type something wrong, it breaks. It doesn't work. But in stats, it always works. If I average 10 numbers, I always get a number. Always. I don't know if the number's worth anything. I don't know if the base data was any good. I don't know what it means, but I get an answer. You see the difference? We trained our business that if it doesn't work, it's broken, but if it does work, it's okay and I can trust it. That's not true. In stats, you always get an answer, and it all depends. The bay out here is an average of 4 feet deep. Anybody want to walk across the bay? Anybody? No? Okay, so we have to know the context around it. So you're going to have to guide your company and your DevOps team and everybody else through discovering what you can answer. Brandon Rohrer, good friend of mine who now works at Facebook, used to work at Microsoft. He did a series of videos for us called The 5 Questions Data Science Can Answer. How much or how many? Is it weird? What kind? And so on. So you can go out and see great videos, very short, very approachable. Definitely check those out. So the business understanding is the number one phase of everything we do. Once we have the problem defined, now we can figure out what data might answer that. You with me? Because I may need weather data or financial data or regulation data or who knows data. By the way, do you want to know the answer to do you want to know the AI and the advanced quantum mechanics I did to fix the grocery store? Anybody want to hear that story? It was awesome. Yeah, you do? Okay, so what I did, I didn't do it. We worked together. But anyway, I'll take credit because I'm here and they can't defend themselves. So they used to have, on the end caps of the freezer thing, how at the end of a freezer, they've got an end cap that's a freezer as well. And they usually put the specials out there, right? Stuff they're trying to get rid of. What they did was they replaced it with one of everything that's in that aisle. And then we used the little magnetic eye from 1950s that noticed when you walk by and it turned on a flickering light in that cabinet as you walk by. So you look at it, you're like, oh, pizza. And then you don't go to the deli because you got a pizza right here. So that's what they did. It was literally solved with an electric eye from the 50s and a flickering light. That was the AI we used. By the way, I'm claiming that's AI because, okay. Yeah. All right, goals for business understanding. Specify the key variables that are served as the model targets. We have targets of things. We either want to know how much or how many, what category is this, and so on. Yes or no, is it odd, anomaly detection, things like that. That's what you're doing, and you identify your key variables. Next, you identify the data sources that might have. So what were the data sources that they needed? Well, they didn't actually need any data from the store because I wasn't trying to change their traffic pattern. I was actually trying to change the behavior. So we went to psychology journals and we looked at what parts of things. Smells are number one. That's why Starbucks works very hard to have certain kinds of ovens in their stores that don't make a bread smell. Did you know that? You ever notice that? Go into a Starbucks, you don't smell bread. You know what you smell? Coffee. They worked very hard to make sure all you smell is coffee. That was they went through tons of models to find the right oven. This is what we were looking for. So smell's number one. You don't really have a smell on a frozen thing, or at least you hope you don't. And so the next thing was sight. And so lights were determined. Colors of lights were determined that would attract attention. Makes me look at the thing. Once I see the thing and I have the comparative effect, I can buy a frozen pizza for $5 or go get one from the deli for $15. I think I'll just do that. I do know how to push a button on a microwave. Everybody with me? Okay. That's what we did there. The next thing, how you do this, you would define your objectives, work with your customer and other stakeholders. You got to bring in lots of people. DevOps, for those of you not familiar with that, is the process of something called shifting left. It means at the very front of the project, you think about testing it. It means at the very front of the project, you think about the security. I know this feels heavy, but you want to do it then because it's really hard to do later. How many of you have ever heard of painting yourself into a corner? How many of you have painted yourself into a corner? How many of you literally painted yourself into a corner? Just me and you? Really? So we're the only honest people in the room, is what I'm deriving from this. Okay. So how do we do that? By the way, I've got a little block here, and it's got a little flask on it. It says, using Azure Machine Learning for Business Understanding. If you would like to see how we do it with our technologies, click into these. If you want to use some other product, then just bypass this. Okay? All right, so now we start a lab. Define our objectives. Read the business case that follows. Open the Charter MD file. And by the way, I've got a handy link to it for you. Open a new tab. Here's our business case. I'll read it out for you guys. The Orange Telecom Company in France, one of the largest operators of mobile and internet services in Europe and Africa, and a global leader in corporate telecommunication services. They have 256 million customers worldwide. Hopefully your ears just went up a little bit. We're not talking about trivial data. We're suddenly talking about actual data, not something that's going to fit in an R frame. You with me? So already your mind is going through some things. They have a significant coverage in France, Spain, Belgium, Poland, Romania, Slovakia, Moldova, and a large presence in Africa and the Middle East. Thank God they're not in America because the rest of the world uses weird dates and stupid decimal places. Customer churn is an issue in any company. Whoa, whoa, whoa. We can't just blow by that. What's a customer churn? What's customer churn? What's customer churn? I've asked you 3 times. What is customer churn? The rate at which customers leave the service. Half correct. You get a C. Anybody else want to give it a go? Oh, come on. I scared him now. Aww. Raise your hand. What? Very good. So if in case you didn't hear that, what he was saying is it's a customer rate. Churn rate. Rate means ratio. Ratio means a divisor, a numerator, and a denominator. That means the number of people who go out versus the number of people who come in. Who cares? If I've got 100 people coming in and I got 50 going out, I'm good, right? Except for one small problem. It is very, very expensive to get somebody to go to a new product. It costs a lot of money to get them onto my platform. It's really hard to get people to leave something, even if it's not very good. They'll still stay with what they have. It's expensive to generate a new customer. It's hard to get people to try something new. Sorry, Windows Phone. Sorry. At any rate, this is very expensive for them. So what they say is this: Orange would like to predict. Aha, there's my data science. That's not BI, it's data science. Predict the propensity. That means whether or not they will. That's a binary, isn't it? Of customers to switch provider, churn, buy new products or service, appetency, or buy upgrades or add-ons proposed to them to make the sale more profitable, upselling. For this effort, they think churn is the first thing they'd like to focus on. There are 3 questions. In business intelligence, you can answer lots of questions with 1 cube. In data science, 1 question, 1 model. 1 question, 1 model. First thing you need to let your company know is when we're doing a data science project, Every question you ask me is another project because it's different data and it's a different algorithm. Everybody with me on that? You agree with that? Okay. You'd be surprised how many businesses don't know that because they're used to stand up a SQL database, ask it lots of questions. You get one question, one model, one project, so get the right one. They've decided customer churn is what they want. So what we do is we open up our project charter document, and I think that's this guy. Yeah, here's the project charter, business background, scope, what are we trying to build, what will we do, how is it going to be consumed, who's on the project, what's the metrics, what are the qualitative objective, reduce user churn. Let me tell you something. After, this says I've got over 30 years of experience in the IT industry. I've got way over 30 years. I'm very old. And let me give you a little secret I've discovered painfully over the many years of my life. When you go into a project, define the success criteria so that you can end it. Do that at the start. Many politicians could be taught this lesson. Go in with an exit strategy. Seriously. Go in with an exit strategy because the customer, after you create the database they ask for, will say, oh, that's nice. Can we put pictures in there? Well, we could have, had you mentioned it at the beginning. Well, can we put that in Chinese? Would that go? Can we put that in Chinese? Well, I could have if I'd have set the code page up like that. I can export everything and redo the whole project. Yeah, let's do that. So make sure you have the success metrics going out. You with me? This is real world pain talking to you. Okay. All right. Here's our plan. You need milestones, timelines, and a short description. I don't want to do this. Too bad. If you don't know where you're going, any path will take you there. If you want to actually do something, this is another Buckwoodyism. You're getting all these for free. What gets measured gets done. What gets measured gets done. That means what doesn't get measured doesn't get done. Okay? All right. Oh, I think I've beaten this one to death. You know the general idea, but there's an architecture diagram in here. You need to identify where the sources of data are. Worked on a problem one time for predictive maintenance. Not preventative maintenance, but predictive. And I was having a devil of a time. They collected this information around temperature sensors around the world, and I was getting really good results and then really crappy results, and then really good predictions and then really crappy accuracy, and then bad recall and then great F1 score. And I'm thinking, what's going on here? And what it turned out was, even though they were the same machine, they collected data at different rates. But since one was giving the answer back every 60 seconds, the other one that was giving data back every hour, they just repeated it 60 times. So instead of having a continuous variable, I had a discrete variable mixed in with my continuous, and it just blew everything up. So you have to go all the way back out to what that data is. This is different than BI. You can't just drag it in. You need to know what you're dealing with. All right. And that, by the way, means you need a domain expert on the team. All right. We're not even through phase one. This is painful. All right. In this case, you verify that you have those first 5 bullets documented. Inside your business case, you're going to identify the data. We just talked about that. And then we're going to bring our data in and we've documented it. All right, finally, oh my gosh, we're down to where we can type some Python. We're in data acquisition and understanding. Again, we're not going to go through the code today because I promised to get you lunch. And I'm going to do my best to get you out of here in the next 20 minutes. But there is a documentation reference. Right-click, open it up when you're ready. No big deal. Here's your goals. Produce a clean, high-quality data set whose relationship to the target variables is understood. That's the other 90% of your day. The first 90% of your day is getting the problem right. The second 90% of your day is this. And then develop a solution architecture of the data pipeline. Unless you want to be dealing with ISDN lines and security protocols, and whether you're using SSL certificates, get somebody on your team that knows how to do that. Stand up a team in your organization and call it something cool and sexy like the data science team, or advanced analytics, or the AI and applied knowledge group. Then people will want to be in your group, and you can make them do things they wouldn't normally do because they'll have a cool title. I'm not kidding. This really works. This is actually how you do this in real life. You get a team together. There is somebody on your team that is ready, willing, and eager and able to do all the SSL certificate management and all the rest. And you want that person unless you feel like doing it. Is everybody with me on this? Who in here knows about SSL certificates? Okay, I got a recruiter in the back. I just want to... Actually, I do have... Oh, yeah, Trish is here. I was kidding, but I actually have a recruiter from Microsoft in the back. So go by and say hello to Trish. Yeah, security, huge, huge. All right. So we developed our solution architecture. You need to lay that out. Visio, Lucidchart, whatever you happen to use. Microsoft Paint. It doesn't matter. You just need to... you laugh. I've done whole sessions in Paint. I've done entire classes in Paint. Not on Paint, because I'm awful at being an artist. I look like a deranged child when I draw. Okay, how do you do it? You ingest data into the target analytic environment. This will be determined by the data security and the data path, the latencies, all the rest. It's best to get it into a big place, just a blob. Just get it in something, okay? If it's not secure, get it up on the cloud. It's probably the best place. It's central. Everybody can work in one place, the whole nine. If it's got security ramifications, carve that out and do it correctly there. Compute over data. With me? Say that. Compute over data. Okay, don't do compute here and data here. That's bad juju. All right. We're back to the mainframe days, guys. Okay, then what we need to do is explore the data. Now this is interesting. You need at least, write this down, a 5num summary. At least a 5num summary. Does anybody know what a 5num function is inside R or Python? Anybody? Yes, sir. What's 5num? Yep. Nicely done. So it's just the basic statistics around the data. You're getting your data shape. You want to know if you've got, you want the mean, median, you want quartiles, you want mins and maxes, and so on, and you just want to look at that. If it doesn't make sense, if I would have gotten, by the way, the mode of the original data set for my air conditioners, I would have immediately seen this number is happening all the time. That's weird. That's weird, right? So I would have, just by doing a 5num sum, anything can do a 5num sum. You can do that in Excel, Python, R, everything is SQL, everything has a 5-number summary, right? If you don't know what that is, write down 5-number summary, go look it up on Wikipedia, great article on that. The next thing you want to see is the data distribution. I love boxplots. They're my favorite. Does everybody have a favorite visualization, or am I just odd? Does everyone have a favorite visualization? No? Really? Me and you. We're it. Really? How about you? Do you have a favorite visualization or no? We're just alike in one thing. We're just the non-liars about that. But you don't have a favorite visualization? Like, what's your favorite graphic? Do you have one? You don't. That's sad, in a way. It's sad that I have one, not that you don't. But the box plot is my favorite thing ever. Box and whisker, whatever you want to call this. It shows a lot about the data all of a sudden. You want to get your data distribution. The next thing you want to find out is missing values. Missing values are huge. They're going to matter inside our computations later. You need to figure out what to do with the missing values. Do you take out the row, the column? Do you do mice? Do you do least component analysis? What do you do? Right? Okay. You look for outliers, things like that. Great stuff. All right, you with me? Then what you do is you need to get a data pipeline to store and refresh more data. I cannot build bricks without clay. I need more data. All right, and then if you want to do this inside Azure Machine Learning, there you go. I have a lab for you. There's the data file. And I actually have this lab done for you partially. You could run this code right now and it would work, but it wouldn't tell you much. What I tell you is I say, set up a variable called df data frame, and we call pandas, which was loaded earlier. By the way, inside a notebook, the environment you're in will carry all the variables through. Stop the notebook and start another one, and you lose all that. How could you solve that problem? Anybody know? Pickle it. She's absolutely correct. You could pickle everything, open a new notebook, and read the pickle, and now this notebook has everything that that notebook did. Awesome, no? All right, here we go. We read in the CSV file. There it is. And then you need to figure out what would be there needs to be 20,468 observations of 29 variables. Anybody know real quick how to do that in Python? df shape. Very good. You could also do that by cheating, which some of you may have already done, and I'm okay with that. By going down here and printing the shape. And I'm old school, so I print shape, and then I add the new line at the end, because that's how I roll. I started in C, not C++, or even C++, which there was never a C++. I never quite figured that out. But anyway, I digress. There was also a Windows 95 and then 10. I don't know, and an 8. Windows 9 never saw the light of day, I guess. Okay, and then there's other things. Now what we go do is we're going to go explore some data. If you'd like to do this, you could paste it into lab, and this first one will tell us, I got all the data. That's why I break it out. I know how many things are in there. You can do that even in Unix or Windows and read the file and count things. I want to make sure that the reading function made it, that I've got the ability. So this is just a straight core test. Next, we need to data explore. We need to load, explore the data focusing on the shape, types, and missing values. Why do we care about types? We care about types a lot because Python will treat objects different than it does numerics and so on. You with me there? Also, categorical variables matter a lot. I won't go into that. I describe it here in your documentation. Questions on this phase? Explore the data. By the way, Excel, a fine tool for data exploration. It's the number 4 tool, I think, when data scientists are polled. SQL, R, Python, and then Excel. I kid you not, Excel. How many of you know that you can highlight a series of cells, press Alt F1, and it'll make a graph for you? Did you know that? You already knew that? Do you work at Microsoft? Do you want to? There's Trish. Trish is right there. I think I pointed her out earlier. I'm just messing with you. No, that does work, Alt F1, so learn your tools. All right. So I'll let you go and replace this data. It puts out nice histograms and box plots and fun things like that. And this is the fun part. And then the nice thing about notebooks is you could now show your non-techie people, this is what we're working on, this is what we found, it's kind of self-documenting. You could also share code among your data scientists by sending them the notebook or having them use this notebook on the Azure Notebook server. Next, we need to create a model. A model is not an algorithm. A model is something an algorithm makes. It's, at the end of the day, don't tell all the data scientists, anybody data scientists in here, just close your ears for a minute. All data scientists do all day is just create Excel functions. That's all they do. There's no data or anything behind it. Literally what happens is you're going to ask it a question, it's going to give you a response. That's what a model is. Now, to get there, that's fairly complicated. It's non-trivial, okay? All right. So, modeling. We talk about how to do that. Here's your goals. Your goals are to determine the optimal data features. For the machine learning model you've chosen, you'll have one of two types. You'll either have something that uses labels, and that's a supervised model. That means you already know the answer for a lot of things, and you're going to guess at the answer for new things that you don't know. This is the way we learn as children. Your mom says, bottle, 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 and you hold up a ball and you say, bottle? And she says, no. And she says, my child has special needs. No, she doesn't do that. She doesn't do that. She says, no, not bottle, ball. She corrects the label. And over time, your brain goes, I see this object, I have the label, I know the bottle. And I predict the next thing I didn't see, this is a bigger one, but it's still a bottle. By the way, when is a bowl not a spoon? I don't know. These are things we can't answer with data science. I talked to you about that. All right. So the deal is we're going to pick a model that fits. And the neat thing is they're in families. So you can't just take every model and throw it at something and hope it works and get the best answer. It doesn't work like that, right? Different families of algorithms. But if we do this correctly, if we started with the right question, customer churn, I want to know whether or not a person will churn, then I automatically know the kinds of things I could use. Regression, I could use naive Bayes, I could use a decision tree. I've got all kinds of cool things I can do. But I know what they are. I don't have to go wandering over and figure out all the math. Is everybody with me there? Okay, so the model by now, because I've already picked the data, and I've already picked what I want to predict, and I already picked how it's going to work, the model's almost chosen for me. You with me there? But we need to build it. To do that, we do experimentations. So we take a bunch of algorithms, an ensemble model, put things together. We tweak the parameters. They're called hyperparameters because that sounds cooler and more people don't know what that means. But it's just parameters. You tune these parameters and you get the best precision, accuracy, recall, and so on. You get your F1 score, your confusion matrix, which is aptly named. And you figure out which one did the best in that circumstance. You run lots of these. It's an experimentation. That's the part that's science out of data science. Once you're done, you put that down into a Pickle Model. The Pickle Model now says, oh, I've been trained, I know what I'm doing. I'm just going to use this output of the Pickle Model from that, and I'm going to give you a prediction back, and that's how that works. And I serve it back out as an API that I call. But we're getting ahead of ourselves. First thing we need to do is do our feature engineering. You need to know which features are most predictive. Interestingly enough, there are data science tools that will help you, and math, that will help you pick the right features to solve a model, which is kind of cool. So you can take a bucket of data, throw it at an algorithm, and say which of those things affect the target the most. Once again, everything's a guess. Everything is probably, and probably changes everything. If you go to your doctor and your doctor says, congratulations, you're going to live, probably. That matters. So you want to make sure, right? I love you, probably, right? That'll buff out, probably. So it matters. So we do our feature engineering, and then we train our model, and then we evaluate our models, and we see if that's the right one. Okay, that's the modeling phase. We have a full series of things you do here, and there's a lab here. Oops, let me scroll up a bit. Looks like I went a little further than I wanted to there. There. I actually do a lot of this model for you because a lot of this is big. I do help you do one-hot encoding on this particular model and a few other things, so you can go see that. But if you want to try this algorithm yourself later, you most certainly can. And it's in the answer sheet. Everybody understand modeling? Okay. And by the way, what I do then is I give two of these. I give you a decision tree classification accuracy in my particular one, and I give you a Gaussian as well, a naive Bayes. And you see which one's the best. And then they both very, very, very close, by the way, but it kind of matters. If you're ever more than 90% sure of anything, you're probably doing it wrong. In data science, it's the only place where you're trying to get the customer not to believe what you said. Where you say, yeah, 90%, nah, I'm not even 90% sure I'm here right now, so I'm not sure how many of you guys are real. You know, this could be a weird dream, right? So 90% is dangerous. This one comes out with a very nice 90% because it's completely overfit and the data source is far too small. You're welcome to try to fix it and let me know what you did. Next, we're going to deploy it. By deploy it, we really mean to operationalize it. You need some way for your users to use it. One could be they come to you and say, hey, dude, are they going to churn or not? Here's a list of customers. And you're like, and you go back in your office and close the door, watch a few episodes of Black Mirror, you know, check out how you're doing on your Amazon store, buy a cool phone cover, come back and go, it looks like about these 4 customers with 80% accuracy, and they're like, oh, right? Or you could do what companies really want you to do is just make an iPhone app. And you just put in there, we did one recently for an insurance company. They wanted the customers to be able to take a picture of the car, and they need to know whether they need to send an agent out to total it out or whether it was something that could be fixed. And so that was just literally an API that the data scientists learned, and we trained lots and lots of recs. And then we did have a problem, though. If you get close to it, it's hard to tell. We had one car that all it was a fender. And they said, yeah, that could probably be fixed. And it was like, no, it was just too close, right? You stand back and there's no car. It's just a fender. It's like, yeah, no, that was what was left of the car. So that was considered a negative response in that case. All right. Okay, so we explained how to do that. The way we do it, by the way, in our Azure machine learning services, we use Docker to abstract out, and we can deploy to Raspberry Pis all the way up to big, gigantic Kubernetes systems that we host. We also use Conda for extrapolation, and I tend to use, if I'm doing any kind of deep learning, I use Keras for that sort of thing. So we try to abstract as much as we can away so that it's very portable whatever environment you go to. We have some places that we need to deploy to IoT, like Navy ships, and they're not connected back to the internet. So the predictive model needs to be on something local, and we have the ability to do that. All right, that's deployment, operationalization. Questions there? Okay, how many of you are writing APIs now? Well, let me ask this. How many of you are doing the models and everything, but it's kind of a manual process in that somebody sends you a bucket of data, says do the predictions or the categorizations, send us the list back. Raise your hand if that's your modus. Okay, good. For those of you that are doing an API type system to where people send a request, then they sort of self-service the prediction. Raise your hands there. The rest of you not doing anything, or? What else are you doing? Anybody? Something else? Okay, so for those of you that are doing where you're responding to an API in-house, you've got a system in-house that's answering the web API calls, raise your hand. Okay, something on some cloud somewhere. Cloud is somebody else's computer, by the way. That's the technical definition. Okay, good. All right, good. That helps me understand kind of where we're at here. All right. That's the operationalize. And by the way, once again, know your audience. Most people live in Excel, especially business people. So we do have, within Excel, the ability to call out from a column of data that's in Excel out to an API and put the answer back in Excel. So you can do that. Azure Machine Learning has it built in, but you can use it with other things as well. So your person can sit there and you can say, I need to know hair color, age, weight, height, income, nationality, all that, and I'll tell you if they'll churn or not. So they type that dutifully into their spreadsheet, they click a button, these 3 people look like they're going to churn, I need to go visit those people before they leave our company. Does that make sense? Okay. Put the hay where the cows are. Make sure you get them the answer in the tool they use the most. Don't make it hard. Your job is to make hard things simple. Then we're done. So here's the model file. Really super simple. It's just a pickle export. And then here's the pickle import. We usually give back, by the way, and I kind of did this one for you. Here's the columns we encoded for this one. Looks like age, income, call drop rate, and a whole bunch of other stuff. And then we do our encoding for our one-hot encoding. And then we send an input data frame out, and that will give back a yes or a no. And then in here we have customer. By the way, I have an example in the final one that actually tries this, that actually gives it a go. And in there it was somebody who has a bachelor's degree, makes more than $120K a year, is a doctor, and then under age it said 12. And I'm thinking, wow. And so I went to my boss and I'm thinking a lot of people are going to know where this 12-year-old, and by the way, he's single, so ladies. And he said, no, that's the age of their contract, you idiot. And I'm like, oh, okay. Because that seemed odd, you know? I mean, it seemed odd. I was still eating dirt at 12 years old, so. All right. Now we come to the final part, which is the customer acceptance. The customer acceptance. And we are 2 minutes away from landing. And we will hit 1 hour exactly. But I'm going to leave time for questions. If you're super hungry, bail. But if not, stick around for questions, because sometimes they get really interesting. Okay, what are we doing here? We want to make sure it works. You've got to check with your customers. You're not done. If they come back and say, yeah, I know that person's not going to churn. I know they're not going to churn. And you're like, don't just dismiss that. The model says they will. Don't do that. Say, wait a minute, why do you say that? Because you may be missing something. You may be missing something. So definitely check and see your assumptions are accurate. Does that make sense? Okay, go like this. Go like this. You were just clearing your hair. You weren't saying no, right? Okay, just checking, you know, because it's okay to disagree, right? I was wrong once. At least I thought I was. And then, okay. So we got to do that, and then you need a path to retrain. You need to come back to what's called ground truth, because you will have something called model drift. Model drift is where I'm predicting things, and it's getting more and more inaccurate. Could be for 2 reasons. One is I could be overfitting. Second is I could be underfitting. I don't have enough data and the conditions have changed. So I may need to redo my model. The nice thing about Docker, the nice thing about Conda, the nice thing about Keras is if I've abstracted all that and I've made it a web service, I can replace it. And as long as I make my contract of what you send and get back the same, it doesn't break anything. It's kind of nice. You may also need to version your models and so on. Okay, we tell you how to do it. We tell you what it's done. We tell you how to create an exit report and then how to do your testing and your handoff to the team that's going to take over this, because you're moving on to bigger and better things. If we pop out to that, there's the exit report. Look at that. We've already typed everything in for you. Customer, enter customer name. I did this one place and the consultant had forgot to take out the placeholders. So it's like, dear sir or madam, as the case may be. So make sure you change all that. But we do all the paperwork for you. Everything's there so you can describe it. So we've done a lot of typing for you in this. Testing and handoff, documentation reviewed, and this is your workshop wrap-up. If you'd like to learn more, there it is. We're 5 seconds away from 12:15. Are there any questions? Yeah, in the back. Yes, sir.
Thank you. You mentioned pretty much the most hard part of the data scientist, the project, the business understanding.
Yes, sir.
And I think my experience tells me that the second hardest is the customer acceptance.
Yeah.
Do you have any suggestion or
yeah, great question.
Or best practice for managing the user acceptance?
Yeah, that's a great point. So his point was this: the hardest thing is to tell them, to get the problem from them. And then the second hardest part is telling them or getting them to accept what you're going to do. This is going to take 6 months, or we can't answer that, or we can answer that, but we're going to need 2 people, or whatever. How do you get them to accept it, and how do you deal with that? This is why you have a team and why you have allies within the business. Make sure I look for super techs. I ask somebody, how good are you at Excel? I ask everybody in the room, who's the best Excel person in here? Can I show you something you don't know? And there'll be some finance guy or something that, I'm pretty good at Excel. Really? You think you're good? And I'll show them something cool they don't know in Excel. That's my ally. So then I'll get him or her to help me sell the message, because you do kind of have to sell it. Great question.
Yeah. So we actually currently got Power BI licenses.
Okay.
So how would you say that Power BI can replace, over here?
So the question was, how does Power BI fit into this particular paradigm? So Power BI has the ability to make calls out to an API and then display the results. So you could have a series of customers inside the Power BI data set, scrub that, call to the API in another cell, and or in another widget. And when you're in that widget, it makes the call, does the prediction, and lights up or turns green the right people, and so on. Yeah, it'll be a dashboard, yeah. So reading the data and so on. So the question now here becomes, wait a minute, how do I get all this data? For the training, you're going to train the data and then you're done with it. That's over on the machine learning model side. However, all of these and Python libraries have the ability to read from Azure Storage and AWS and other places. And SQL, even on-prem, if you have the Power BI gateway, you can use the SQL on-prem. Great question. We do have templates for Power BI. You'll find those in this documentation references. Yes, sir.
Hi. This is the question regarding the Excel sheet thing that you said. So we have a lot of clients who are really the Excel type, the old types, as you just mentioned. And this is one of the caveats I would say in our team currently, that they want everything in their old-fashioned Excel with a new row that is generated.
Of course they do.
Yeah. So
after you make a beautiful visualization of maps with heat points and everything else, somebody will look at it. That's amazing. Can I have that in Excel?
Yes. So I don't know, is this the correct place? We have some time left. If you could give some insights regarding what you just said.
So the question really revolves around, how do I get people to trust the data and trust a new way of looking at something? And the answer is, I always let them peel back the covers. And I'll tell you, a good answer is Power BI, where you can show the nice visualizations, but then they can get right back to the sheet and export it to Excel if they'd like. So I'd recommend digging into Power BI a little bit, or Tableau, if that's your thing. I don't know Tableau well. Other question?
So in the TDSP, the first letter is for the team. How do you use this framework in kind of the agile, Jira, Confluence, whatever? How do you marry those approaches?
Yeah, great question. So we didn't talk a lot about the team part. You can use Get or GitHub and so on. I actually have a series of articles on my blog called DevOps and the TDSP. And it talks all about integrating in the teams. If you go to the documentation right down here at the bottom, there's a full article on how to do this within a team. All the parts you need to do.
Where does the performance fit in a little bit? Because, for example, I have SLA that requires us to return, the risk score through API in 500 milliseconds.
I love those.
Yeah.
I love those. So that goes at the very part, at the front. So whenever I do a project, and I've done this for more than 30 years, whenever I do a project, I only do two things. I need your requirements and your constraints. Requirements are what it must do, and constraints are things it can't do. And I write those on a board. And once I get those down, then when I have to make my T-chart of, well, we could do this, but you said 30 seconds, this is 35. And they'll go, well, around 30 seconds. business people are used to metrics. They want a number. They want something they can hold you to, and that's great. No worries. They may have a reason for that, so don't dismiss it. But you've got to, you note it in your documentation, right in the business understanding. We have the following requirements. We have the following constraints. Now they're right out in the open, and when somebody goes, why did you not just use this? Because our constraint was they wanted to do a predictive model on a Commodore 64 with $3 of support. And so we basically flashed the number 42 in front of them every 30 seconds. That's what we could afford. Okay, one more and we'll... I have to tell them what a Commodore 64 is? Okay, y'all look that up. Yeah. Yes, sir.
So this is actually an extension to an earlier question. So how do you answer questions like, why does this model work this particular way? Why is your model
That's a great one. And we'll end on this. And if you have other questions, I'm happy to meet you outside, but I want to let these people get to lunch because some of them look like they're getting desperate. And that scares me. Because I'm an IT guy and I'm not good at defending myself. So how do I describe that? And some of them you can't. And in fact, for GDPR, there's certain things you're not allowed to use, because certain things are a pachinko machine. They're not going to tell you how they determine. They're non-deterministic. So you can't use those models at all. So how do you describe the math? I would start with those 5 questions data science can answer. I would go into that. That will lead you to a discussion of what to use when. And there's a bunch of really good tree maps out there on families of algorithms. And then lead them gently into the stats. Don't go any further than the stats. It's just, for one thing, they're not going to get it. And the second thing, you're just going to irritate them. Never try to teach a pig to sing. It annoys the pig and wastes your time. I didn't say that. Definitely be as communicative as you can to the business, but don't go overboard and geek out on them because they're gonna dismiss you. Yeah. We can take one more. Let's do one more.
One more?
Last one. This guy right here. All right. Yeah, the question was, how do I fit this into Agile? What's the biggest pain point? Continuous integration. Automated testing is really hard, and I covered that in the article series. They're going to have what's called a manual testing step, an MTS. They're going to hate it because they try to get those, because they just want to click a button and it just keeps flowing. In data science, you have to explain to them there's no way to deterministically test an outcome. So for instance, say, you know how we all go to lunch at the same time every day? But we really don't. Most time we go at 11:30 to beat the crowd. But some days we don't. Imagine if you had a continuous test and everything breaks if we don't all go to lunch at 11:30 every day. And they'll go, okay. And say, for my step, you're going to have an MTS, a manually tested step. It's just the way it is. That's the toughest part, manual testing. Okay.
All right. Thanks for coming, everyone. Was that? Thank you very much.
Thank you, everybody. Have a great day.